Hi guys, this is Matt with MonsterVR, and we're back to C# learning. Once again, I'm using a book called Learning C# Programming with Unity 3D by Alex Okita, and just opening up small little chapters and building out little tiny projects and hopefully learning a few things or two about C#. So today we're going to discuss this. What is this? Well, we're going to get into that. So, this is chapter 4.9, and we'll get started. So we have Unity opened up here. We have MonsterVR opened up. Where's mine? And there we go. There's my mouse. Okay, cool. So, what happens when a class needs to refer to itself? In most cases, a class can use its own properties in fields and not get confused what variable is being referred to. For instance, we can take a look at a basic class that might look like the following. So, let's go get rid of this. Bow. And we go float, my float. And then we're going to do a public void, which means it returns, it doesn't return anything. And we're going to call this function assign my float. We're going to pass it a float f variable. Just to keep how you do things straight. Okay. Ooh. That was my alarm going off. Alright. And then what's going to go in here is my excuse me, float. I'm a little sick, so if I sound a little congested, I apologize. Cool. So we have my float is equal to f in the assign my float function. Now right underneath this function, we'll write another float called public void show my float. Bam. Go back. Go back. Go back. There we go. Easier way to do this, but there we go. And we're gonna go debug dot log my float. Boom. Bam. Alright. So we have two functions here. We have a function called assign my float, which passes a float called f, and then we have a public void show my float. This runs my float, which is, and then turns that my float into equal to f, and then show my float is just a debug.log function called my float, and it's going to print out the variable my float. So here we have a class which we can add to a CS file. We'll look at public class my this and see that it's got a, oh shoot, In most cases, a class can use its own properties and fields and not get confused in the variable it's being referred to. For instance, we can take a look at a basic class that might look like the following. Bam. So basic class. Here we've got a class which we can add to the example file. We'll look at public class myThis and see that it's got a field called myFloat. We've also got two functions inside of the class. Oh. Public class myThis. Oh, okay. I did not see that. I didn't see them write a class in there. So, my bad. Public. So we're just going to create a class within a class called myThis. Blah, 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 public class. And then we're just going to give it a big fat boom, boom. We'll do that. And we will do that. Cool. This. Cool. Perfect. That's what I forgot to do. We've also got two functions inside of the class that assigns the myFloat field within the myThis class. So myFloat, myThis class. In the first function, we assign myFloat to a parameter, and in the second function, showMyFloat, we simply send the myFloat form from within the class to the console panel. In use, the full code would look like the following. Okay, got some more stuff. Float, assign myFloat, debug log myFloat, and we're gonna go in the start method. Void start. Let me just make sure. No, it's outside the. Actually, we'll do this. Command X. I'm gonna make sure that this is. Cool. So that goes to myThis. Perfect. And outside of the myThis class, we're gonna run a void start function. Perfect. That's what I needed. And we're gonna go myThis empty is equal to new myThis. Oh, what is going on here? That's weird. This. What's that? New my is equal to new myThis function. I'm gonna go mt dot assign myFloat. I'm going to pass it a float 3.0f. Bam. Bam. Assign myFloat. Assign myFloat. Cool. And we'll go mt dot show my float. All right. Let's see what happens, shall we? Let's go Control S. Save this. We'll go. Let's get out of 3D mode. We'll take the main camera, and we'll just throw the main script on the camera. Cool. Open up the console, and we'll hit play and see what happens. Oh, there's an error. What's the error? Parsing error. Let's find it. Must start. I never closed out mono behavior class, which is boom. So we click on this, and there it is. Perfect. Control S. Awesome. Disappear, and it did. Hit play. Bam. And we print out 3 to the console. Alright, let's see why we printed out 3 to the console. I'll go back to the code and back to the book. In the start function, we print 3 to the console. There's no confusion because my float is never used in a situation where its name may be confused with another identifier. The situation changes should we change a parameter name and assign my float. For example, from float F to float my float. Let's try that. Float F to float my float. And then we go, my float is equal to my float why would this capitalize? Oh, that's why. Bam. Bam. Perfect. Okay, and let's change this one. Man, I just did all those floats. It's alright. Let's get rid of this. Thank you. Killing me, Smalls. Control S. Alright, let's see what happens when we run this. 0. If we add the assigned this float my float function, we'll get some rather unexpected behavior. If we use this to assign my float and the my this class using the following statement, we will not get the same behavior as before. Unity 3D lets us know something might be misleading by prompting us with the following warning. Oh, he created another. Got it. So they created another. They didn't change this out. Should we change parameter name and assign my float? We add the assign this float my float function to the my this class. We'll get some rather unexpected behavior. If we use this to assign, we look at the simple solutions. So what's the simple solutions? Oh, what I did was I did do the simple solution actually, which was it brought it to the 0. It's funny. This sends a 0 to the console panel. This is because in the function assign this my float, where we assign the my this variable my float to the assigned this float argument my float, the function assigned the class variable back to itself. The local scope within the function took precedence over the value stored inside of the class. We can correct the behavior by adding the keyword this to the function. This to the function. Where's this at? I think it's coming up next. Okay. So assign this my float, this dot my float. So we're gonna go this dot my float is equal to my float. Bam. Alright, we'll hit Control S and we'll hit play. I don't know what happened. Spare that. I came up 3 again. Oh, because of the 3. Yeah, it makes sense. Because of the 3 float. Okay. Back to code. Perfect. With the addition of the keyword this to the function above, we can specify which version of the myFloat variable we're talking about. Running the start function again, we'll get the expected 3 being printed to the console panel. It's easy to avoid the requirement of this keyword. Simply use unique parameter names from the class variables and you won't need to use the this keyword. There is no unexpected behavior if we super flawlessly use this keyword anytime we want to. The keyword does as you might expect it will. In both of the versions of the following function, we get the exact same behavior. So if we were to do this myFloat or here. So if we change this to float F, and so basically and we change this to F here. Cool. So that would be the same as if we wrote it like this. My float is equal to F. Crazy. Of course, we don't want to use the both in the same class at the same time, but it's important to know that either version can be used, just not at the same time. The use of this can help make the code more readable. In a complex class where we have many different variables and functions, it sometimes helps to clarify if the variable is being assigned is something local to the function we are reading or if the variable is a class scoped variable. Using this, we can ensure that the variable is assigned to a class variable and not something only in the function. Cool. So let's just pick one. I like this, so and that's the name of the thing, so we'll keep that one. Cool. Awkward names. Naming variables can be difficult. Below we have an awkwardly named variable integer called my badly named integer in an awkward class. That's funny. So I'm just gonna create a new script. We'll just do this. Cancel. We'll go back to Unity. Go back to Project. Assets. Create. I'll create a new script. and we'll call this one my badly, oh, and we'll call it my awkward class. I like it. Awkward. Class. Wham! Alright, let's open up my awkward class in MonsterVR, and there it is. Cool. Like that. Alright. So, we have class my awkward class. And inside that class, we're going to call an integer, and we'll call it my badly named integer, and we'll go equal to 0. Cool. All right. You have that. Then we have a function that also happens to have a variable named my badly named integer inside of it. So we have, let's get out of here, and we'll go void poor named function and we'll pass it a integer my badly named integer 7. Go. I wonder what would happen if we run this. Oh, nothing. It's not even the start function yet. So hit Control S. Save it. Cool. Things get strange if we were to need to call upon the class's badly named integer rather than the function's badly named integer. That's funny. The class scoped integer my badly named integer still exists, which is right here. It still exists. It hasn't gone away. The same integer my badly named integer inside of poorly named function, which is right here, is interfering with the same integer at the class scope, which is there. My app class. Poorly named function. So we're gonna go click that out. We'll go debug debug.log this dot my badly named int. My badly named int. Oh, why did it do this? Oh, weird. Look at that. What's this? Cool. Pardon me. And 7, and we'll go take this. We'll Command C. Turn Command D. Cool. All right. The debug.log before or after the declaration of the function's bad integer will send a 0 to the console panel. Will it now? Will it now? Command C. No, Command S. No, Command S. Perfect. And we'll just take this, look at camera, we'll take out the example, and we'll put my awkward class in. Cool. And we'll hit start, and we'll go to the console, hit start, we'll clear. Nothing got printed. Lies. Lies! Unless that's supposed to be in the start function. The debug.log before or after the declaration of the function's bad integer will send a 0 to the console panel. Without the this keyword added before the identifier, we assume that we're using the function's named version of the variable. If this keyword had not been used, then we get a conflict with the first use of badly named integer within the poorly named function. C# has noticed that the badly named integer is declared again and ignores the class scope in the center of the same name. So let's do this. Let's go back to MonsterVR, and we'll just create a start function so I can see what the heck this thing is even doing. Cool. And we'll just print poor named function. Just like that. Command save. Now let's run that. Let's see what happens. 0, 0. Yeah. All right. Cool. Now we got that worked. All right. Debug.log before or after the declaration of the function's bad integer will send a 0 to the console panel. Without this keyword added before the identifier, we assume that we're using the function's named version of the variable. If this keyword had not been used, then we'd get a conflict with the first use of the mildly named integer within the poorly named function. C# has noticed the badly named integer is declared again and ignores the class scope integer of the same name. Crazy. All right. What have we learned? In general, this is somewhat superfluous keyword. I don't know what that superfluous keyword. The necessity of using the keyword this arises only when a name of parameter in a function matches the same of the variable in the class where the function's parameter appears. When naming variables and functions, it's best to keep a consistent pattern. In general, many people use longer names at the class scope. For instance, the following code uses a pattern of shorter and shorter variable names depending on the variable scope. So, we're going to write this real fast just to show you. And these are all terrible, terrible, terrible naming conventions. Terrible. Just get rid of that. Bow. I'll get rid of that. Bow. Okay. So what you'd want to do is go my int. And actually, you know what? I like variables. I like to do the camel case, which is, we'll go my int perfect is equal to 0. And then we'll go void my function. See, it looks so much more cleaner. Bam. You're missing a little guy right here, aren't you? Perfect. Perfect. And we'll go int my int is equal to mi. Oh, I guess we're passing this too, which would be integer mi. Cool. And then we'll go my int is equal to m I int. M-I-N-T. Huh. That's actually just M-I-N-T. But that's like busted. At the scope of the entire class. Oh my! I didn't see that. What? Later. So he created a new thing called myInt there. Okay, cool. Got it. At the scope of the entire class, the integer is my integer. Within the function, my function in my class, a local variable only visible to my function is called MINT, which is right here. The variable from the function's argument list is simply mi, which is right there. There are obvious limitations to using a convention like shortening variable names. It is very easy to run out of letters and end up with unclear variable names, but it's a simple place to get started. This isn't a common practice convention by any means. It's one that I've personally become used to using. Yeah, not me. These sorts of personal conventions are something that everyone needs to invent for his or her individual use. I'd expect you to find your own convention for naming variables. The flexibility of C# allows everyone to have a personal style of writing code. Identifiers aren't the only place where one can find self-expression through code. Another way to express oneself through code is deciding to use a for, while, or do while, or a for while or a do while loop. Both can be used for the similar tasks, but the decision is ultimately left to the programmer writing the code. For any reason, should you feel like you prefer one method over another, you should follow your own intuition and write how you like to. Programming is a creative process, and writing expressive code is a process just like any other form of art. Cool. So, that is the end of the chapter. Not too shabby. It's pretty easy, pretty simple. Once again, my name's Matt. Thank you guys so much for watching. I hope that you guys are getting some stuff out of this. I know I do. It's a good refresher for me, and I learned a bunch of cool stuff. Next time, we're going to be turning ideas into code. I'm guessing it's going to be kind of like a pseudocode little thing, but we'll get into that later. Once again, thank you so much for watching, and I'll see you guys later. See ya.